topic is, how can we avoid the risks of unreliable, manipulated or unconstrained AI or pseudo-AI and ensure the world gets the benefits AI can deliver? We're going to run the session as follows. First, I shall introduce you to our panel, who will help us unpack this topic and then introduce the subject. After that, each of the panel members will set out their views, and then we'll turn to a Q&A session. Finally, depending on time, I may invite the panel members, if they have anything else to add, to do so. I will sum up, and we will aim to close at about 10 past 1. So, to introduce you first to the panel, we have Professor Frans Coenen of the University of Liverpool, who has a 30-year research track record in AI, machine learning and big data analytics. He is currently particularly interested in machine learning and big data analytics in the context of unusual data sets. He is also interested in data mining over encrypted data and applications of machine learning in the fields of personalized health, infectious diseases, and AI and law. He currently leads a small team working on many aspects of data mining and machine learning. France's current funded research, he's working on the application of machine learning techniques to extract information from legal documents and on intelligent agents directed at the smart utilization of data from laboratory analytic instruments. We have Dr. Santo, who is the Chief Scientist for the Cybercore Division at Idaho National Laboratory and has over 25 years of experience in the information security industry. Her research focuses on deception and the role of cultural values in cybersecurity events. Recently, she has begun researching various aspects of artificial intelligence and machine learning, including the relationships between human cognition and machines as related to AI and machine learning. Presently, Dr. Santo is furthering her research on modeling cyber behaviors by culture. Other areas of research are data resilience, cyber physical systems, and industrial control systems. Thirdly, Clive Spenser has been developing advanced software solutions using AI, expert systems, logic programming, and rule-based systems since he finished his master's at Imperial College in 1986. Clive helped set up Business Integrity Limited back in 1999 in order to exploit some innovative research into the automatic generation of insurance proposals. He remained an active board member at BIL from then until its successful sale to Thomson Reuters in autumn 2015. Clive currently leads Logic Programming Associates development of VisiRule and represents them at Barclays Eagle Lab. Clive shares his time between London and Cork, where he has worked with local researchers and startups looking to develop exploitation strategies for their AI research. And finally, Peter Garraghan is a lecturer and EPSRC Fellow in Computing Science at Lancaster University. His research expertise is empirically studying and improving the performance, resilience, and sustainability of massive scale distributed systems in the face of societal and environmental change. His recent research agenda includes designing new high-performance and sustainable AI and machine learning computer infrastructure. Peter has industrial experience building large-scale distributed computing systems and has worked and collaborated internationally with the likes of Alibaba Group, Microsoft, BT, STFC, and the UK data center and IoT industry. Finally, I myself am Andrew Lee. I'm a visiting research fellow at the University of Brighton. I'm head of AI at Hello Done, where I'm designing systems to validate natural language conversation agents. I've been an AI practitioner for many years. So now I'm going to introduce the subject. So this is, how can we avoid the risks of unreliable, manipulated or unconstrained AI or pseudo-AI and ensure the world gets the benefits AI can deliver? Or to put it more colloquially, fake AI, what can we do about it? Or even AI abuse. This question has both ethical and technical dimensions, so we can tackle it in a number of ways. As ever, even in the pandemic, AI remains topical, partly because people hope that it may be part of the solution, and partly because data analytics is so often presented as artificial intelligence. Even formulas have now been promoted to being algorithms, which if one believes some sections of the media have only just been invented. We see, therefore, that there is genuine applied AI and pseudo-AI. The ubiquity of AI, pseudo-AI, and abused AI, if there is such a thing, brings multiple issues, such as 1. Bias in AI and machine learning. Arguably, any bias in AI simply relates to predispositions in the data being learned from. The bias originates in the behaviors which originally gave rise to that data. Again, arguably, what is portrayed as bias may simply be that which is socially undesirable. certainly to be addressed, but how? This brings me to my first answer. Machine learning is all very well, but we need to be jolly careful what the AI actually learns from. Secondly, fake news is topical and ranges from actual fake news created for nefarious financial or political gain, not that I can think of any examples. Can AI be used to detect this fake news? I think it can, though again, if we are going to train systems as to what is genuine, we do risk the echo chamber effect. On the flip side, some perfectly genuine news is being labelled as fake by those who oppose its implications. Maybe AI could label genuine if disturbing news. Thirdly, is AI or the misuse of AI in any way responsible for the mismanagement of the pandemic, if indeed it has been mismanaged? My view on this is that any mistakes have been made by people. In this regard, AI modelling is simply a tool. That said, we need to make sure our AI modelling software is of the highest quality because, of course, broken tools can give rise to erroneous decisions. And lastly, if AI is used for decision making, how can we protect society from unreliable, unconstrained, or even manipulated AI? This is the thorny issue of AI testing, which is necessarily hard since AI is at its core non-deterministic. That almost defines AI, doesn't it? It often learns or uses random initialization, and so does not always, even when working properly, give the same answers on each time. So in short, how do we ensure the world gets the benefits of AI, as with any technology, can be used or misused for good or ill? To tell us how to do that and what we need to consider, I'm going to turn to our panel. So firstly, may I invite Frans to give us your view, please.
Thank you very much, Andrew. So I'm going to present my own take here, following nicely on from Andrew's introduction. So I guess this is a multifaceted question, and for me, one that is not new, but one that's been around for many years, but it's becoming increasingly more relevant as AI becomes increasingly more mainstream, and the phrase AI has entered into the popular parlance, frequently mentioned on radio and TV. The question kind of raises the perennial "what is AI" question, but don't worry, I'm not going to go there. So we have unreliable, manipulative, unconstrained, pseudo-AI. What can we do to avoid these but maintain the benefits of AI? And reflecting on this and on my take on this, my answer is education. But let me explain. So let's start with the first one, reliability. And I'm interpreting reliability here as trustworthiness. Can we trust AI systems? Can we rely on them? And for me, the answer is sort of. Yes, in many cases, but we need to recognize when something does not seem right. And this is where explainable AI, XAI, becomes very important. But I also believe education is important here. Users, eventually the general population at large, need to be educated. I'll get to what I mean by educated in a little later. But they should be able to recognize when a system is not behaving as it should do. And I'm afraid concepts like p-values, chi-squared scores, Pearson correlation coefficients are all meaningless to many end users. So we need to have some education here about what these things mean, and we kind of need to simplify them. Thinking about manipulative AI, and it's a kind of different thing, isn't it? I'm interpreting this as AI fooling the human, using human unconscious bias and emotions to gain some end. For example, to buy a product. And salespeople, of course, have been doing this for millennia. And we kind of all do this, don't we? I mean, the trick to being a good manager is to convince people to do things that they don't necessarily want to do, and in the process, make them think it was their idea in the first place. The difference with AI is that we can now do this at scale, enormous scale. But we need to think about where is the boundary between an AI system that helps us find the film we might want to watch and an AI system selling us a film after convincing us that it is a film we want to watch? And it's a tricky one, isn't it? The idea of manipulative AI also makes me, I don't know if anybody saw the film, or it came out 5-6 years ago, called Ex Machina. I thought it was a fascinating film where a computer scientist gets sent off to to do a Turing test on a robot. And he sets off and he starts asking questions of the robot. The robot is a sort of humanoid robot, has a human face and hands, but the rest of it is mechanics. And after a while, you realize that the robot is starting to manipulate the questioner. And I won't give away what happens in the end, but it's quite an interesting take on the classic Turing test. But how can we avoid manipulative AI? And my answer is, again, education, raising awareness, enhancing understanding, getting people to know what AI is. I mean, we all cringe when we hear people with influence talking on the radio about AI who clearly have no idea of its roots and history, let alone what it is.
Yeah.
Moving on, unconstrained AI, and I think the panel will be interpreting this in various ways, but I interpret this as the use of AI where we'd rather it would not be used. The idea of placing limits on AI, the idea of constraining the domain. Do we want to do this? I'm not so sure we do. And if we do, how do we define this? One person's perfectly sensible AI-based defense system is another person's perfectly abhorrent AI-based weapon of mass destruction. Where do we draw our lines? And Andrew's already alluded to this. I think this raises the question of the ethics of AI, the subject of EPSRC calls, BCS accreditation, dedicated modules across the HE sector worldwide. And I think as a community, we understand the needs for ethics in what we're doing, but much of the time we're preaching to the converted. It's the unconverted we need to reach. And of course, then the question is, do the unconverted wish to be converted, or do they have a vested interest in remaining unconverted? These are complex issues, but again, I think the answer is education. Andrew referred to pseudo-AI. We have a lot of claims going through the media about what people call AI and what isn't. A classic example, and I think, Andrew, you kind of referred to this, is Ofqual's A-level AI algorithm, which was done in the UK during the COVID-19 crisis to predict what A-level students might get, high school students' final exams. And when this first came out, the AI community all nodded knowledgeably and thought, oh yeah, they'll have trained a neural network to do this, and they'll have got a training set and they'll have tested it. I kind of think I know that. And then it turned out that what they were using was an equation with 4 variables. So the question then is, and the people who did this are called Ofqual. The question is, were Ofqual lying to us, or did they simply not know what an AI algorithm was, but thought it would make their message sound much more convincing if they used the term AI? I mean, let's be charitable here and let's assume the latter, in which case the answer again is just education. So I've sort of, been banging on about education, and you might, I can imagine people thinking, oh, well, Frans would say that, wouldn't he? He works in a university and he runs AI courses, so he's bound to promote education. But I'm not talking about degrees or HE courses. and talking about public awareness, I kind of like to draw parallels here with the domain of cybersecurity. We've seen much recent work on cybersecurity, items on television, radio, communications from banks. I had one from the bank only this morning. And as a consequence, we are all becoming increasingly aware of the risks that we're taking, especially when we're using social media and online shopping and the data trail we leave. We should aim at something similar in the context of AI. And I see this as campaigns educating the end users of what it is and what you can reasonably anticipate. I think I'll leave it there, Andrew, and allow someone else.
Thank you, Frans. That was very, very interesting, especially the take-home message, off-call needs educating, which is a certain degree of irony in its own right. So I'm not going to argue with it either. Now let's turn to Shah. Dr. Sample, please.
Thank you, Andrew. And Frans, great talk. You actually hit on several of the points I was planning on hitting, so mine might be a little bit
I was afraid
shorter.
I might do that.
That's all right. Well, at least, hey, we're thinking alike. This is all good. So anyways, I'm going to talk a little bit about what I call AI foundations, because when we're talking about how we can trust AI and when AI runs amok and all these other areas that we're hitting on here, trustworthy AI, of course, is what we're all aiming for. But I would challenge us to think about the foundations that we put into this. And so when we talk about those, I would say that, you know, we recognize that AI solutions are black box solutions and that they can be tricked. And we can even talk about all the different ways that they can be tricked. But I like to say that I break it down into the data, the algorithms / systems, and the models. And when we look at all of those and we put those together, we build on all that, we can come up with our pieces that we need for explainable AI. And of course, Frans did bring up explainable AI. It is well studied, and it appears to also have several people modifying the definition to make it fit whatever they're selling. So I will say that when we're talking about explainable AI, we're talking about evidence-based output, user-specific explanations. It's accurate, and it has knowledge limits. And this is really important, this last one on the knowledge limits, because when we're talking about, especially in software in general, we have a tendency to take something that works in one environment and then we apply it to another environment. And then we're shocked when things go a little squirrely on us. When we're talking about this in terms of AI, I would say that we need to really understand more about our environment in general and understand the limitations of what our algorithms are doing, because we do, and this actually takes us back down to some of the lower layers of what about the data? So when we do all that, I do have slides, but they're not, I didn't bring them up. I have them sitting on another computer right now that I'm kind of scrolling through here. We actually put together a little model, and it's not a perfect model by any stretch, but it's a good way to help conceptualize things. And I put at the very bottom, we have to have resilient data, and we don't necessarily check our data. Everything else, if you can't get the data right, everything else is going to go wrong. It's just, we talk about AI and we want to make it talk about the intelligence built into AI and how it can learn new lessons. But if you don't teach the student the right lesson in the first place, everything goes wrong from there. I oftentimes liken it to in America, we have a lot of homeschooling going on even before COVID. And I said, so it's kind of like teaching a child creationism and then sending them off to university and expecting them to perform really well in the sciences. It's not going to happen. So similarly with our AI, if we don't get the data right, we don't get the rest of the solution going right. And how do we make our data resilient? That's actually one of the areas of research that we're looking at INL. And by that, we mean, we know that in information security, we have the infamous McCumber model that says, confidentiality, integrity, availability, non-repudiation. But it really doesn't look too closely at data as it's being ingested. We say, oh, we look at it in processing, at transit, and at rest. But we really don't take that first step and say, well, are we putting garbage into this in the first place? How would we know if we're putting in garbage? And so what we're doing is attempting to marry context, descriptiveness, and time to confidentiality, integrity, availability, and non-repudiation, so that when you receive something, you receive a data piece using physics, some people call it physics-based data to validate what you're seeing. I like to call it physical data because I don't like to limit it to just physics, but we are using this approach in our examination of industrial control system data, so that we can say, well, if my status in my security system is telling me everything is okay, but my water tank's overflowing, or I'm processing, my valve is open and it's been open way too long, how do I reconcile that? And how do I know what's actually happening here? So that's the data piece. Now, we also have, beyond that, one level above data, we can go into what we call our resilient systems and algorithms. We know that historically, that's actually been a whole industry, cybersecurity, built on breaking algorithms. Why would AI be any different? We actually have some folks working on red teaming AI. So how are you going to break the algorithms? How do you break the supply chain? How do you trick it into these other areas without just using the data? There's already plenty of published research on that. And then as we move up the model, I like to say the one that I find the most elegant is tricking the models. So how do we make our models resilient? If I trick the model, or I can have the advantage of hacking something without leaving any real traces. And so we see this with a lot of weight manipulations. We've seen this in cases where AI has run amok. Sometimes we see this when it gets out of its natural environment. So we put all these together. We have the foundations that we need for our explainable AI. And once we get to that point that we can pull all four together, explainable AI, resilient models, resilient systems, resilient data, then we can start to trust our AI. Until then, I don't really know that we're going to be able to say yea verily and without always looking over our shoulder. So we need to have more, I would say we need to have more overarching solutions and start thinking about how we're actually using AI. But I would also say, if I had one takeaway, if Frans had the takeaway about education, my takeaway is going to be about the data. Every time I hear somebody go up and give a talk about AI, at least in the States, they always say, we need more data. And then it's, oh, and we need better data. So I'm going to say that I'm going to challenge us to look at all of these levels here of resilient data, resilient systems, and resilient models. But I'm going to put the large emphasis right now on good, high quality data that is verifiable. So it's not just that somebody's giving me a good data set to train off of, but that I have a method to verify it.
Excellent.
So with that, I will pass the baton.
Yeah, thank you very much indeed. Very interesting talk indeed. If people, by the way, as they're listening, would like to have a think about what questions they might want to ask or points they might want to raise, we can put them on the chat function, and then we can accumulate them ready for the discussion later on, depending on how much time we've got, of course. So may I turn to Clive Spenser, please?
Hi, Andrew. Thank you. So to me, this is quite a broad topic and can be interpreted with a great amount of freedom. Quite often I find myself substituting AI with something completely different because I don't know what AI is, and it to me is almost just a label that can mean anything to a lot of people. I would say a lot of this is, to what degree would you trust a device, a computer, to make a decision on your behalf? I mean, in the world historically, we have relied on humans to make decisions that govern our behavior and make rules and allocate things. And as we are looking to hand more and more of that over to pieces of metal and silicon, you know, you have to think, am I comfortable with this as an individual? You know, Frans talked about education, and certainly education is important, and next speaker spoke about data, and certainly data is critical. I would say for me, testing, because from what I've seen over the last 30 years is, you know, you can build systems in general that seem to be incredibly clever and do quite interesting things that can impress people. But at the end of the day, until they're tested and tested and tested and tested ad absurdum, you know, there's always at the back of your mind, well, you know, I know the nature of software, and I know there's always possibly some combination that wasn't ever envisaged that will create havoc. So to me, trust, on a personal basis, I'm pretty skeptical, but I do get in planes that are fly-by-wire, not because I believe that they are provably correct, because theoretically they're unlikely to be provably correct, but they've been tested to such an extent that it's highly unlikely that they're going to fall out the sky. And that's a judgment that I've come to using the education system that has educated me about software, and the fact I know they're tested beyond all reasonable doubt. The one thing I would say about data, especially with this modern emphasis on what's now called deep learning or machine learning or whatever you want to call it, my concern there is actually that, you know, you can give it as much data as you want, but from my limited experience, where we've re-engineered models based on historical data, we've ended up with a model that's backward looking, that kind of replicates almost how decisions were taken in the past. Doesn't mean they were right, doesn't mean they were valid, and doesn't mean they're modern or current or reflect today's ethics and values. So I think that the whole data-driven thing isn't just a question of veracity of the data or the accuracy of the data. It's also the context of the data and whether you want to train an automaton to replicate the results that you have managed to produce in the past, which may well have been wrong, incorrect, or dubious. So the final thing I would say is, to me, humans make decisions all the time and we trust them. Now, sometimes they make bad decisions. Sometimes they give us the wrong diagnostics. Sometimes they give us the wrong information. And that's part of humanity, and we learn, hopefully, to forgive and forget. The difference to me is that computers, once they've built their models, will make mistakes, but they will make mistakes on a consistent basis. So if you give them the same data, they'll come out with the same mistake. So at least you have a chance of preparing it. Whereas with humans, there is a problem due to inconsistency, which is, if you catch me on a bad day, I may give you a different answer. So I think education is important because it will help people understand that, you know, you're not going to get the same answers that you would get were you to have a human do this. But you may actually appreciate that what you will get are safer answers or more consistent answers, which have been rigorously tested again and again and again. And therefore you should derive some confidence and from that some trust. So if the first presenter was emphasizing education and the second presenter was emphasizing data, my emphasis would be on testing. That's it, Andrew, back to you.
Thank you very much. And I absolutely agree. Testing, very, very, very important. Thank you. May I turn to Peter Garraghan now, please?
Hello. So just for context, for those who joined late, I'm a systems researcher. I build infrastructure and deploy it around the world. So that's kind of my perspective. I don't want to pontificate about stuff which I can have an opinion about, but I really want to stick to my core expertise to talk about the things we're talking about in companies. But before I go on to that, a very small note from the other panelists is, I think we shouldn't underestimate the power of public discourse. So think of the power of language and how it changes, and how much we grate our teeth in the past of how a word becomes synonymous. So a great example is, resilience and reliability are the same thing. They're not, but the public will think this from it, and that drives policy making, companies, marketing from it. So I'm quite confident in the future that, let's give it a few years, people in the public discourse will think of all software as AI. AI in general is just every piece of software, every algorithm. For them, it makes no difference, honestly, what it is from there. So we have to maybe invent a new term for it, or we'll stick to our guns and say in an academic sense, which is preach to the choir, as Frans so kindly said. To the public, we have to be aware that their understanding of software, is very different to what we think from there as well. I think as well, there was a comment about the nature of AI, and one thing it's still not clear to many of us is the point of AI in public discourse, is it something to give cognitive ability to be equivalent to an individual in terms of decision making, finding patterns, or is it a mechanism or a tool that augments my understanding from there? There tend to be two camps, but in public discourse, the public either think, it's something that can help me as a human, or it's replacing me as a human from it. Even when you think about it, I think the problems we're talking about, unreliable, unconstrained, fake news, that stuff's been around for thousands of years. You think about it, go back to Hellenistic period of Europe, go to the Edo series, go to espionage, go to public discourse, persuasion, the fall of Rome. All those problems in terms of public disinformation, decision making, prediction, that all is all done by a human. And humans do make mistakes from there, but at least we have a baseline as another human. I can talk to someone and say I can kind of gauge or gauge your kind of understanding of how your worldview thinks from that. But the thing is, with some quotation of AI, it's at a much larger scale, as Frans mentioned, and it's very, very precise. And you might argue that now, instead of it being a human, being a machinations of a person who's like some sort of dictator in a traditional sense, or a Roman sense, or a more modern sense, it's now gone to a device. And the question then is, what is that device? Is it a tool for myself, or is it something else that gets its own? I don't like to use the word own life, but it's its own creature. And I think the public discourse, they're still not sure about this, and I think even research is not too sure what we're trying to go from there as well. Anyway, that was kind of one side point. The thing I really want to get to the heart of is, I want people in the panel and the audience to picture a world maybe 10, 20 years time. We now have rolled out a new infrastructure. We have 5G, maybe you have AIG or MLG, what we call it from it, a whole new infrastructure completely built. Imagine what that looks like. So we can imagine a world where every single device in your home has some sort of algorithm inside it. Your pen has an algorithm device, kitchen appliances have a device from there. Transportation, logistics, either has man in the loop, or person in the loop from there, I shouldn't say man in the loop, and making decision making from there in terms of it's either telling a person to say, okay, here's my decision making, I've augmented you, or it's being replaced to say, algorithm decided for ourselves. And I think Clive made a good point about, currently we use systems and tools that, we're relatively trusting in terms of it's not going to break on us from there. But imagine a world where everything is augmented or controlled by these type of algorithms from it. There's a lot of problems with that. So I could talk about the resiliency and potential attacks in terms of persuasion. Imagine time infrastructure went offline because a machine learning algorithm got some data or was designed to do so, you exploit it. But I want to talk to something that's close to my heart, which is the problem of sustainability and consumption and the economic models that govern this. So there was a paper from Amazon in natural language processing, I think earlier this year, and they ran a massive algorithm, a huge algorithm from it, and to basically trace some data. And they said at the end of the paper, don't run this again. It was too expensive. Like it wasn't worth the cost from there. Okay, it's kind of a funny one-off, but you think of that in a greater context. I think a big problem is that I've talked about it in a previous lecture, that 10% of the world's electricity usage is ICT. AI is not being modeled yet. And when it gets modeled, the numbers of having 2, 3, 4, 5, 10, 15% don't seem that far off. So Bitcoin uses 1 to 2% of electricity usage right now. So, and that, that's a very, very specific and very intense subcase. But imagine every single device and every single system uses some sort of machine learning. That's really, really expensive from it. And I have two really interesting questions about this. The first question is, imagine we built an algorithm, I'm not saying algorithm in a loose sense, and the algorithm designed to answer more of the big questions of humanity. Like, let's say, how can we find immortality? Or how can we solve climate change? Or how can we solve world hunger. That one's it's more achievable. That's sort of political problems or geopolitical problems. What was the cost of that? Okay, how much are we willing to? If I said to you, yeah, we can solve that, give me 10 years of the world's electricity usage, and I'll probably give you an answer, maybe. From it. It's almost like Hitchhiker's Guide to the Galaxy about that machine that takes many centuries to figure out an answer and give you an answer that I don't understand. But the cost of the problem I'm seeing in systems now is that there's a massive mismatch between the usefulness of an algorithm, especially in machine learning, and the cost of actually running it in the first place. It's designed by that. If I say to you, okay, I have a model, I want to train my model to be 92% accurate from 191, and the cost will take me 2 weeks. And I might say, is that a good trade-off? It's really hard to say from now. Okay, at least I'll say probably not from it. It's a model I'd never use again from it. It's really bad. AlphaGo, I think it's 5,000 devices, and it trained for several months. And you could argue that's a good cost because it beat a grandmaster. But I want people to apply this beyond, the tech companies with this massive amount of money and equipment going into society when this is much more disseminated. You're training and inferring and deploying these models and doing these things. The cost is going to be huge from it. And I'm not seeing any planning from government policy, for example, from it, or even, tech companies to some extent, but it's more about, it's going to get away from us, and the type of cost we're going to do is going to be absolutely huge from it. So it is going to be a panacea in terms of helping us in things, but I think the cost would be absolutely astronomical from it. And it goes back to this idea, which it's called gratuitous cognitive ability, which is, look at the human or the natural world. Energy and thermodynamics is a driving force in everything, okay? Or in other words, systems are intelligent, like humans, use more energy. It's very over millions of years, it's evolved that we are very good at user efficiency, and things that are more intelligent or better use more energy usage. So the Garragans, the worm, you might think of from it, or like a fruit fly, uses very little energy from it. A human uses much more from it in a chemical basis. Machine learning doesn't have that ability. It's kind of, if I throw energy at this for how many hours or weeks or months, it might not be useful from it. So I think what we need, the next phase of machine learning I'm seeing from a system perspective is trying to align to say, imagine a world we said, okay, we can have dumb AI, okay, stupid AI, but we give it low energy. If I gave it more high quality energy that's available, it should do more things from it. And the question is, how do you align these things? Because the way we design these things, I say, is very ad hoc. From the algorithm design, from the machine itself, deployment, the training, the software, the framework, all that stuff, it's very, very expensive. So if you talk to guys at Google or Microsoft, they'll say to you, as a machine learning deployers, what they say is, we draft the model, get some data, we train it until we run out of time, or it gives an accurate good enough from it. It gives a good nice accuracy, but there is really a secondary thought is the cost of doing so in terms of the electricity consumption from it. So for me, I think a vision for infrastructure would be, if we could model with the rise of renewable sources, if we have low energy and no energy usage, do we accept that the intelligence of our system is going to be less? It's going to be dumb because we haven't got the energy usage. Versus if it's high energy, then this thing can be more intelligent from it. And I think that type of thinking will help us to make AI less constrained, because the danger of not doing this way would be you have a bunch of really expensive, power-intensive AI devices that aren't really useful. So do I need my pen, like my pen here, having a really energy hungry model from it? Probably not from it. But currently there's a really big mismatch of how to do this. So that's kind of positive faults. But the takeaway I'd say is infrastructure will come at some point. It's going to be in its current form incredibly unconstrained from a geopolitical point of view, from a data point of view, trust point of view, but also a sustainability point of view from it. And that's something I really care about. That's it. I gave way.
Wow, thank you very much. That was fascinating. So we've heard a lot of really interesting thoughts from people there. I wonder now if the audience would like to ask any questions. And I saw one that popped up on the chat function. Rakesh Bhatt, if I pronounced that correctly, you were asking about decision making. As far as decision making is concerned, how do we rely on our data? Have I said that correctly? I don't know if you want to speak. If not, I'll just I'll put that question to Shah, if I may.
Yeah,
Right.
yeah. This is the same question.
Yes.
Yeah. For the quality of data we should have in order to get the right decision.
I think it's quite hard. The old bandwidth isn't doing its thing there, is it? But the question you asked on the chat was, as far as decision making,
Yes.
how do we get to actually rely on our data? Shah, is
Yes,
that
yes.
one you could take?
Yes.
Yes. Go ahead. Somebody else is talking? Okay. I was saying that actually that showed up in a similar question showed up in the chat, and I said something to the effect of, use it when possible, if we can baseline our data using physical data as well as what we believe we're sensing through our AI or in our machine learning systems. If we can tie these two together and come up with that baseline, we have a better chance of coming up with the veracity that we seek in this. Now, in some cases, it's going to be impossible to get that physical data. I actually threw a shameless plug because I had an article that just got published on fake news, and it kind of ties to all of this. When we look at, depending on the environment, we look for certain things to guide us on data. So if we're a photographer, you're looking at lighting and color and things like that to help guide the eye, and that's how you get what you call your ground truth. If you're looking at fake news versus the boring truth, you'll look for certain linguistic clues that we don't normally think to look at because we just say, oh, well, I'll just read this. This looks interesting. But when you actually break down into each of these different discipline areas, what it is that does define the ground truth, then you may or may not be able to say if something's patently false, but you can at least measure a distance from what you know to be accurate.
Okay, thank you very much. We've had some observations pop through on the chat channel as well. Andrew Lowe, you had an observation. Would you like to make that on the video? I'm not sure if everyone can hear me. No, okay, maybe not. Max, I believe you wanted to put in some thoughts.
I just wanted to talk about accountability, which hasn't been mentioned. I mean, this year we had this horror where a mutant algorithm went insane and ruined children's exam results. Well, of course it didn't. There were human beings behind that, but they didn't suffer at all. There was no human accountability. It just blamed on an algorithm, whatever that might possibly mean. We all use equipment that isn't intelligence. I rely on traffic lights. Every day I drive anywhere. But if the traffic lights are wrongly set and they're green both ways and there's a massive crash, a human will be held accountable. But with AI systems, if we're not careful, we're going to have something where no one is accountable. So if you apply for a job and you don't get it, or you don't get a loan, or you don't get a scholarship, or you don't get insurance, that can just ruin your life. And the answer to why you didn't get it can't possibly be allowed to be the computer said so. It needs to be a nameable, identifiable human being who is prepared to justify that decision. Now, once you make once you decide you're going to have accountability of specific humans, a lot of things follow. Certain systems would never be used because no human will be brave enough to get up in public and try and justify the results. It's not like playing chess against Kasparov. It doesn't matter if you can't justify it as long as it wins. If I turn Andrew down for insurance and can't explain why, there should be legal sanctions against that. Now it's getting more serious with the impending arrival possibly of self-driving cars. I mean, if I'm in a car and in broad daylight I drive, and there's with no apparent problems with the car at all, in broad daylight I drive into a bus stop and kill 4 people, there's every chance I'm going to go to prison. But if a self-driving car does that and all the people in the car are actually on the back seat, none of them could control it in any way, who is accountable? Is it going to be Elon Musk accountable personally? I rather doubt it. But if it needs to be a clear, identifiable person. Now, if it were me and I sent that car out, I'm not even in the car, I've sent it out with my children in it, I would expect that I must be accountable. And because I'll know I'm accountable, I will never allow that to happen. I will never send a car out with no one, no competent driver at the wheel, with my children in the back of it. That would be ridiculous. And I think part of the answer has got to be to take these issues much more seriously before it goes too far. We're already reaching a point where it's actually very hard to say who's made these decisions, and we've really got to rein back on that. And if that means some applications aren't fielded, that might be a good thing.
Okay, thank you. Maybe we're going to wind up with almost needing AI controllers, just like we have data controllers in GDPR. Did any of the panel want to comment on that, Peter?
Yeah, so I think, I'm sure many people in the audience would know that, the aeronautical industry and other industries, they do have, a long process of even their software. They have to go through a lot of different verification, different approvals from there. And I'm not going to be surprised if quotation, the machine learning will do the same process. And like you said, they've already discarded this one. No, we can't use this one. We cannot verify this. So it's not accepting of it's not to the standard we need from there to Brazilians. So there might be a whole set of very useful algorithms, very good from there, but they'll probably never see the light of day in a certain context because they have to go through the procedures from it. So I think that just, as we know, those things will catch up eventually. Standards do come in many decades from there. So I think I completely agree with Max. That's a really big issue, and I'm gonna be surprised at some point a common phrase will be the AI did it. It wasn't me. It wasn't me. Something like that. It'll be something like that from
The
there.
mutant algorithm did it.
Yeah, the algorithm did it from it. Yeah, that'll be the blame. Every organization will say the algorithm's fault, not my fault. Sorry, I'm not accountable. So that'll be public discourse is one thing. I'm sure the media and the news can talk about the stuff and that they will weave that away. But in terms of mission critical systems, I have more confidence because people there aren't stupid. They've done this for many years and they care about life. So there's a reason why after the 1950s, particularly in the 60s of the aeronautical industry, they really put in really rigorous procedures. And I'm pretty sure they're currently doing this right now in terms of quotation of AI of how they actually put the software into systems. It's still the same rigor from them. Not going to deploy like a ResNet model into an aircraft from their decision making from it.
Thank you. Maria Kubrick, you were commenting.
Sorry, Shah has I think Shah's.
Yeah, I wanted to add in on this last thread here with Max. So Max, you kind of hit on something that I find very fascinating, and I didn't include in my discussion on AI, and that is this gap between human intelligence and artificial intelligence. And we really are still learning a lot about decision science in general. And when you try to look at how the human brain, if you try to map all the neurons in the human brain, and you try to map that over to an artificial intelligence system, you're going to find there's a huge gap. We still don't understand how we make decisions. And one of my favorite examples, it's not really an AI one, but it's kind of a logic for how the human brain works. When I came to try this little stint here in Idaho, I realized I was going to need a vehicle that had, that would be pretty rugged and be able to drive around in pretty adverse conditions. So I sat down with my husband and we said, let's go through the logical list here, okay? We need something that's four-wheel drive. We need, small SUV, doesn't have to be too big because you're driving it. Blah, blah, blah. Go through this whole list and we get it down to 4 cars, right? And when it came to the final decision, I did the very female human thing. And I said, I will take the blue car. Okay, so when we actually make our decisions, we move between our neural networks, our decision trees, heuristics, all this other stuff. But in the end, our decisions tend to be emotional. And we really have not figured out how to make AI truly emotional because we don't understand emotional intelligence well enough to break it down into all the bits and bytes that have to come into play. So
that's very interesting. It brings also the question of, are our emotions in fact heuristics for dealing with life? Are there something we evolved to help us cope with complexity very quickly? In which case, maybe we will start having AI with emotions as being the fast and efficient way that doesn't require vast amounts of electricity to do things. Maria Kubrick, you were making some helpful comments on the chat. Did you want to come in at this point?
Hi, thank you, Andrew. No, I just wanted to actually ask our panel members on their views on this, regulated versus free reign AI, because there's very little about this kind of area at the moment, and I think some of the examples that Max and Charmaine mentioned are exactly in that area. So, just interested in the views of others, really.
Thank you. Does any of the panel have a response to that?
Well, I was just still thinking about what Max said, actually, which is going to take a while to think through, which is if you had a self-optimizing algorithm, so you put in place some initial algorithm that said it knew how to do some sort of optimization for distribution of cars and buses and the sort of thing we saw earlier today, and then you put a twist on it, which is, well, I'm going to introduce some genetic mutation crossover capability, so this algorithm will be able to see how it performs and learn how to improve itself. And then 5 years down the line, all the products end up going to the wrong place and there's a total kerfuffle. It's not clear to me whose fault it is. Is it the fault of the people that put the initial algorithm in place, or has it now transmutated to such an extent that it's the people who put in the AI mutation capability to do self-learning on a big scale? And at what point did that accountability move from the initial people to the people who were in charge of the transformation? And then following on what Marja says, Marija says, well, what about the regulation that should encompass that? And it seems, looking at the chat, maybe that will follow after the science. But yeah, I've never thought of that until Max just raised that. So thanks for that, Max.
Thank you. This whole issue of regulation does also bother me, because the wrong regulation could actually stop the benefits of AI in its tracks.
I think the challenge of regulation, and we've kind of touched on this, is the definitions and how we express all this, and when we get how we get the lawyers involved, and that all sounds like quite a challenging thing. Years ago, when I started working on AI, we were working on electronic charts and automated navigation systems for ships, as it happened. And one of the big problems we had was determining who is responsible if a ship crashes into a rock that wasn't on our electronic chart, but was on the paper chart. And in the end, we decided we would just put a disclaimer on it and saying, we're not responsible for anything here. And you kind of see that in car navigation systems, where you switch it on and a thing comes up and you have to press OK before you can continue, which says that the manufacturers aren't responsible, which isn't really what you want here. So I think there's enormous challenges in bringing in regulation. And I agree with Andrew. The danger here is, if you say, OK, we're not going to do AI in X, do you then I'm simplifying this, do you then stifle what the research and opportunities that exist out there? I think it's an immensely difficult problem.
Yeah,
I think to add on that as well, it really depends next decade or so, the public discourse and political world of what AI is. So going to another type of domain. So let's say you're a security enthusiast, you're a lock-picking enthusiast, for the sake of an example, yeah? If I recall, to own a lock-picking set, you actually need to tell the police, hey, I have one. It's, I actually have permission to do so. I wouldn't be surprised if there was some sort of problem in the future that there'll be some sort of algorithms you cannot touch. You cannot build these as a hobby anymore, full stop. There'll be some checks to say, okay, you can tinker in your own system about algorithm, but you can't deploy, you can't do this. But the political will is it so valuable? So currently AI, in the government, I'd say it's very unknown, it's a very new thing, it's very lucrative. But the next 10, 15 years, depending on which way public opinion sways, I can see it being incredibly regulated to banned, full stop. It's too important to the government, it's too valuable to us, we want it, but the public, you can't use it, full stop. Researchers can, you need permission. Almost like a biomedical research, you need permission to get access to these algorithms, maybe. Or it's, very, I say free market, everyone can do what they want from there, go wild. And I think that has very lucrative to the financial and prosperity, but same problems from now. And I think where that needle will sit will depend what happens in the next 10, 20 years in humans from it. I can see both being very, positive, but also very negative, depending on who wants to control from it. And very quickly, Andrew made a really good point early on about the scientific method. This is something I grind my stone about with my colleagues, is that for me, the scientific method is human endeavor. It's human understanding of the world, not the AI, not the system. And so a lot of my colleagues now are saying, oh, yeah, I can do it itself. I don't really care. But no, that's not what it is. From my personal opinion, if the danger of machine learning and research is that if it's getting away of telling you why it is and why the pattern exists, the scientific method or science has been jeopardized. It's going away in terms of falling into our hands of people who have the resource to do the reasoning, and also it's getting away of human understanding of the problem. If I say an algorithm, a magic algorithm on the wall, tell me the secret to immortality, so here it is that science? I don't know because it's not telling what the answer is from it. You know, it's not really human understanding. It's like reliant, and that it's kind of a silly example, but I'm seeing in the last few years, eventually we're kind of giving more away in terms of our data, in terms of decision making and systems. And at what point, it's like the ship of Theseus. So at what point, where is the pivot in terms of, okay, I'm comfortable giving away this stuff to suddenly I'm not comfortable anymore from it. So as a scientist, I do hammer on very traditionally saying it's about human understanding, not the machine learning. Hence, we shouldn't give away too much and say, you know, the machine learning said, the ML algorithm said this, therefore it's right. No, that's not what it is. That's saying it worked. That's only one part of the puzzle.
Okay.
So I go for my soapbox now. That's the thing I'm very passionate about from it.
There's Alexander Gegov, if I pronounced that correctly. You have an interesting question on chat. Would a universal agreement on the boundaries of AI help in distinguishing fake or pseudo AI from genuine AI? Would you like to expand that, or should I just ask the panel to have a look at it?
Yeah, I'd just like to say why I've asked this question. My understanding is that, the different perceptions even within the AI community as to what AI is. And people from different schools of thought, different circles, have a different perception of that. Sometimes they don't agree exactly. And that is why I think that maybe if we try to define these boundaries, at least we'll be able to distinguish the fake or pseudo AI from what we call genuine AI, and whether that would be possible and how would that be possible, if it makes sense.
And do you think the regulation has something to do with that?
The regulations are, I'm afraid I'm not quite familiar with the regulations at the moment. Possibly someone from the panel will know more about that. I've just asked the question. Sorry about that.
No, that's fine. My understanding is actually regulations aren't yet there. It's one of the matters of debate. So I think that's still up for grabs. And the question is which way it winds up going. Does any of the panel have a view on that, on the boundaries of AI? No? Okay. Right. So at that point, I think the subject is sort of coming to a natural end, unless anyone wants to make any other point. So given the time, which is just before 1 o'clock, maybe I'll just I've got a question myself actually, which I wouldn't mind asking Clive. We were talking about testing earlier. You were mentioning the need for testing. So the natural question that springs to mind, this is subject of professional interest to me as well, is how do we do that? How?
I think we need another hour, Andrew. I mean, it is, you know, we do a lot of regression testing, but that assumes that the regression testing that we're doing is based on correct answers to start with. And sometimes you find out eventually after a lot of pain that the original data set and its answers were not actually correct anyway. And we have had cases where we have produced 70-page documents of predicted entitlements, which failed the regression test because of some arbitrary change in word order that human beings use all the time and are generally accepted to be not affecting the meaning of the interpretation of the language. So it is a massive problem. And one last thing, I had a project years ago. It started off with 3 programmers, I think we could call them, and 3 knowledge engineers, and it grew year on year until the team was 3 programmers, 3 knowledge engineers, and 33 testers.
Oh,
so it was the tail wagging the dog. You know, these people, they could churn out more product and more knowledge, but the exponential combinations of results meant they couldn't ever really test it, and the whole project got swamped because they couldn't really convince themselves that it was going to always work correctly.
Right. My goodness, that was not a ratio I was expecting to hear.
Nor one that they were expecting.
No, absolutely not. So we're getting towards the end of the session, so I just wondered if we might whip round the panel for any last thought. Frans, have you got any last observations?
I think we had a really interesting talk there, and it was quite interesting, and I suspected this happened, that there'll be a lot of different takes on this question. And I guess it depends on which level you're looking at. But from the perspective of wanting AI to be used by as many people as we possibly can, I still hold out for the importance of education, although I appreciate testing, the quality of the data, and all these things are important as well.
Thank you. Sure. Do you have any last thoughts?
Yes, I found this panel to be very interesting, fun, everything that I've worth getting up extra early for. I would like to, I think when we're talking about AI, something that I still come back to my original fear, not that HAL will take over the world, but that augmented intelligence in the wrong hands is actually probably a bigger problem that we need to concern ourselves with. And we kind of dance around a lot of these issues when we talk about AI ethics and how decisions are made and things like that. If I had someone who had malevolent intent and they have all this knowledge that we can harness through machine learning, I actually think that's probably our biggest threat to civilization. Not to end on a doomsday talk here. So,
okay, thank you very much. So, Clive, do you have any last thoughts on this?
No, other than it's interesting that all the panelists came at it from different points of view and emphasized their own take. And then Max came in with yet another thing, which was good as well, accountability. So it shows it is a multifaceted discussion here. So it was very enjoyable. Thank you.
Thank you. And Peter?
I kind of resonate. Machine learning and AI is nothing new. Honestly, from it's the same problems from 2,000, 3,000 years ago. You now have, it's just the scale, the precision, and the patterns that you don't see as a human. It's now controlled by maybe a subset of people or its own autonomous system, and the dangers and the prosperity and the dangers that can come with this. And then, and the very last thing I would say is, I would like the ones to go away, think in the next 10 years what's going to look like and how it's going to be used. So, you know, and go mirroring what Frans said, you know, educating yourself and your family about these things, also students from it, but also think in your own jobs when you use this thing, why are you using it from there? It's actually worth doing it from it. How you can build your own system in the future.
Okay. Well, thank you very much, everyone. So just to kind of try and summarize the conversation, that the main points that have come out, there was the whole question of explainable AI and education and understanding what that means, with the interesting side observation that off-call needs educating, which certainly tickles me. Then we had the points about resilient data, that if we aren't building our AI on top of sound foundations, obviously it's not going to give us good answers. And equally with that, resilient models that can't easily be tricked, or presumably resilient to bad data coming in the first place. We've heard about the need for testing and the challenge for that, and actually that might even be a possible discussion topic for another panel, another year. How do we test AI? We talked a bit about the power of public discourse, lovely phrase, and how that's going to influence policy, which of course would, I suppose, include regulations, and that's all up for grabs. We don't know where that's going to be, but some very interesting thoughts also on the cost of very expensive models in terms of electricity, possibly completely swamping and being far greater than the benefit of those models, which was an eye-opener to me. And we also touched upon the issues of accountability that hit us. So thank you very much, everyone. That brings this panel session to a close. It's the first time we've done this virtually. I thought that went quite well, given what technology could have thrown at us, but didn't. So